I was just reading the latest clinical data on sleep and brain waste clearance, and it changes how we should evaluate the link between sleep quality and cognitive aging. Sleep is described as restorative, but this claim collapses a specific biological mechanism into a vague wellness concept. The actual process happening in your brain during sleep is far more active than the word rest suggests. During sleep, your brain undergoes a transformation. The spaces between neurons expand significantly, creating wider channels for fluid flow. This expansion enables a specialized waste clearance system to operate at full capacity. This is not a minor detail. The expansion during sleep increases the brain's interstitial space by approximately 60%. This is a dramatic architectural change that enables a completely different mode of operation. The expansion is initiated by specific neurochemical signals that activate when you enter sleep stages. Adenosine accumulation and cholinergic signaling work together to trigger this transformation from waking to sleeping brain architecture. The practical question is what happens to the waste products accumulated in your brain during waking hours and how sleep enables their removal. The mechanism is called the glymphatic system, a term combining glia and lymphatic to describe a waste clearance pathway that resembles but operates through different anatomy than the body's lymphatic system. The glymphatic system is a macroscopic waste clearance system that utilizes perivascular channels formed by astroglial cells to promote the elimination of soluble proteins and metabolites from the central nervous system. It functions mainly during sleep and is largely disengaged during wakefulness. This is crucial. The glymphatic system is not continuously operational. It is a sleep-dependent cleaning mechanism. The critical substrate being cleared includes amyloid-beta and tau proteins, molecules that accumulate during waking and, if not cleared during sleep, can form toxic aggregates linked to neurodegeneration. The molecular mechanism involves aquaporin-4 water channels located on astrocyte endfeet. These channels facilitate the convective influx of cerebrospinal fluid into the brain parenchyma and the efflux of interstitial fluid containing waste. This is not passive diffusion. It is active convective flow driven by osmotic and hydrostatic pressure gradients. The glymphatic system physically flushes waste from the brain tissue during sleep. Natural sleep is associated with a 60% increase in the interstitial space of the brain, resulting in a striking increase in convective exchange of cerebrospinal fluid with interstitial fluid and enhanced clearance of potentially neurotoxic waste products, including amyloid-beta. The supplied clinical evidence supports a narrower but specific conclusion. Sleep facilitates measurable waste clearance in animal models. Human correlates suggest poor sleep quality predicts cognitive decline, potentially through reduced glymphatic clearance. The relationship between glymphatic function and sleep quality is not bidirectional. It is sleep quality that determines glymphatic capacity, not the other way around. Poor sleep means impaired clearance. Sleep architecture refers to the organization of sleep stages, including light sleep, deep slow-wave sleep, and REM sleep. Different stages produce different neurochemical states that influence glymphatic effectiveness. Slow-wave sleep is when glymphatic clearance reaches its maximum efficiency. During this deep sleep stage, the interstitial space expansion is greatest and waste clearance peaks. REM sleep, while important for memory consolidation and emotional processing, does not appear to support glymphatic clearance with the same efficiency as slow-wave sleep. This means sleep quality is not uniform across the night. The composition of sleep stages matters. Nights with insufficient slow-wave sleep mean impaired waste clearance even if total sleep duration is adequate. Sleep fragmentation, where sleep is interrupted repeatedly, disrupts the sustained interstitial expansion needed for effective glymphatic clearance even if total sleep time remains constant. When you do not sleep well, the glymphatic system cannot operate fully. Amyloid beta and tau accumulate, Over months and years, this accumulation can progress to pathological aggregation. The timeline matters. A single night of poor sleep impairs glymphatic function for that night, but the system recovers. Chronic poor sleep creates cumulative debris that recovery cannot fully reverse. Aquaporin 4 water channels on astrocyte endfeet are key components of the glymphatic system, facilitating the convective influx of cerebrospinal fluid into the brain parenchyma and promoting clearance of interstitial solutes such as amyloid-beta and tau proteins. Do not imply aquaporin 4 as a drug target without citing clinical trial evidence. The glymphatic system is a relatively recent discovery, and therapeutic interventions remain experimental. The glymphatic system shares common ground with lymphatic drainage systems throughout the body, but operates through different anatomical substrate. The brain lacks conventional lymphatic vessels, so this alternative system evolved. Understanding glymphatic function reveals why chronic sleep disruption is linked to cognitive decline. The mechanism is not just about feeling tired. It is about progressive accumulation of debris that cannot be cleared. When you look at the proposed sleep-to-cognition mechanism, the key limitation is that this discovery is relatively recent and most supporting evidence comes from animal models. Most direct lymphatic observations come from mouse models using 2-photon microscopy to visualize fluid flow. Translating these findings to human sleep physiology requires acknowledging what we still do not know with certainty. Do not overstate the completeness of understanding of glymphatic function, as it is a relatively recent discovery. Do not imply the glymphatic system is the only waste clearance mechanism in the brain. Individual factors influence glymphatic effectiveness. Age-related changes in aquaporin 4 expression, variations in cerebrospinal fluid production, and differences in astrocyte physiology all affect how efficiently each person clears waste during sleep. Age-related decline in aquaporin 4 expression may contribute to reduced glymphatic efficiency in aging brains, potentially explaining part of age-related cognitive decline when combined with sleep disruption. What does hold is the mechanism. During sleep, cerebrospinal fluid flows through perivascular spaces. Amyloid-beta and tau are measurably cleared from the brain during sleep periods. The glymphatic pathway is real and documented. What remains uncertain is the precise relationship between glymphatic system disruption and cognitive outcomes in humans. The mechanism is sound. The outcome predictions remain hypothesis-based pending more human research. The important limitation is that not all cognitive decline can be attributed to glymphatic dysfunction. Multiple independent pathways lead to cognitive aging. Glymphatic impairment is one contributing factor among several. Sleep deprivation is associated with amyloid-beta accumulation in animal models. Poor sleep in humans correlates with higher amyloid-beta levels in cerebrospinal fluid and brain imaging markers. The direction of causation remains incompletely understood. The important limitation is the experimental model gap. Mouse brains operate under laboratory conditions with consistent circadian cycles. Human brains operate under highly variable sleep conditions with shift work, stress, and sleep disorders as confounds. Circadian rhythm disruption from shift work, jet lag, or social jet lag impairs both sleep architecture and glymphatic function. The effects are not simple. Multiple neurochemical systems are disrupted simultaneously. Sleep disorders, including sleep apnea, insomnia, and restless leg syndrome, all disrupt glymphatic function through different mechanisms. Fragmentation reduces continuous clearance. Insufficient slow-wave sleep reduces clearance capacity. Nocturnal oxygen drops may impair aquaporin 4 function. The practical implication is that sleep optimization is not luxury self-care. It is biological maintenance. consistent sleep duration, maintained sleep stage architecture, and circadian alignment are waste management imperatives. So why does sleep quality matter for brain health? The answer is that during deep sleep, your brain physically expands. Aquaporin 4 channels open and cerebrospinal fluid flows through perivascular channels, clearing accumulated waste. Without this nightly clearance, amyloid-beta and tau accumulate. Over time, accumulation leads to aggregation. Aggregation triggers inflammation and neurodegeneration. Cognitive decline follows. The mechanism is clear. The timeline is extended. The modifiability is absolute. Sleep quality directly determines glymphatic function. Glymphatic function directly determines waste clearance. Waste clearance protects cognitive capacity. The key distinction is between waking and sleeping brain. These are not the same operational mode. Waking is optimized for processing and responding. Sleeping is optimized for maintenance and waste removal. Trying to optimize cognitive function while neglecting sleep is like trying to maintain a car without ever changing the oil. Processing happens during use, but maintenance only happens during shutdown. Separate the mechanism from the outcome. The mechanism is well characterized. Sleep produces interstitial expansion. Expansion enables glymphatic clearance. Clearance removes amyloid beta and tau. The outcome depends on cumulative clearance over months and years. If you want to protect your cognitive capacity through sleep, the priority is consistency. Consistent sleep duration, consistent sleep timing, and consistent sleep stage composition matter more than occasional perfect sleep. This episode is educational interpretation of established neuroscience about the glymphatic system, sleep architecture, and cognitive aging. It is not medical advice. Sleep disorders warrant evaluation by sleep medicine specialists. The goal is understanding the glymphatic mechanism accurately enough to evaluate sleep and cognition claims with appropriate expectations and enough nuance to distinguish nightly molecular function from long-term cognitive outcome. Measure what is actually supported. Not sleep satisfaction scores, but objective measures of sleep quality, including stage composition and fragmentation. Cognitive changes are measurable through standardized assessments, not subjective feeling. Recognize that your cognitive capacity depends on nightly glymphatic operation. This is not a feature you can skip, it is a requirement. Sleep is when your brain cleans itself. The biological reality is that sleep is not downtime. It is active maintenance. Your brain works harder during sleep than during passive waking rest, pushing cerebrospinal fluid through specific channels to clear debris accumulated during the day. If sleep quality matters this much for cognitive function, the intervention starts with sleep fundamentals. Duration consistency, timing consistency, and circadian alignment are the primary levers. Secondary considerations include sleep stage composition. Protecting slow-wave sleep becomes important because that is when glymphatic clearance reaches peak efficiency. Factors that reduce slow-wave sleep, including sleep fragmentation, excessive alcohol, and aging, all impair glymphatic function. Conversely, factors that preserve sleep architecture enhance clearance capacity. This understanding transforms how you should evaluate sleep interventions, not as comfort improvements, but as mechanisms that preserve biological waste clearance and protect long-term cognitive function. Cognitive capacity depends on the stability and consistency of your sleep patterns over months and years. The glymphatic system does not build resilience. It requires ongoing operation to continue providing protection. Follow the evidence boundary. The evidence clearly establishes glymphatic clearance during sleep. The evidence supports sleep quality and cognitive outcomes as correlated. The precise mechanism of how glymphatic disruption translates to specific cognitive deficits remains incompletely understood. The glymphatic discovery represents a major paradigm shift in understanding brain health. It explains why sleep disruption carries cognitive consequences that persist beyond simple fatigue effects. The precision of the glymphatic mechanism deserves a conversation that matches it in specificity. Sleep is not wellness trend. It is fundamental biology. Your brain requires it for waste management and cognitive maintenance. Your brain cleans itself at night. That cleaning is not optional and cannot be fully replicated during waking hours. Protect the conditions that enable glymphatic operation, and you protect your cognitive future. Optimize the protocol, protect your brain, and I'll see you in the next data set.